Hi, welcome to the channel. Here I post challenging math problem video daily. If you like this video, then give it a thumbs up and subscribe to the channel. So without further delay, let's start. Today we will solve all the three problems based on this JEE Advanced 2022, the complex number problems. Okay, so the first problem is problem number 4. There are two problems from the paper 1, question number 4 and 5, and there is another problem from complex number which is in paper 2. So let's solve this first. So the first problem says if z be a complex number where non-zero imaginary parts, if this expression is a real number, then we have to find the value of mod z square. Okay, so let me write this expression. Question number 4, this is the given expression. So it is said that this is a real number. Okay, so you know from the property of complex number, let's say if z equal to a plus ib, for example, then z bar equal to a minus ib. So if we take the difference z minus z bar, so this is 2ib, and z plus z bar equal to 2a. Now if a number is purely real or a real number, so this is 0. So we can write this is for a number which is completely real. So which means this complete expression is uh, 2 plus 3z plus 4z square divided by 2 minus 3z plus 4z square, and uh, equal to which this means z equal to z bar. So for z equal to z bar, the complex number z is a real number. So this we can write taking conjugate of this number. So 3z bar plus 4z bar square, 2 minus 3z bar plus 4z bar square. Okay, now what we can do is we use componendo and dividendo. Okay, using componendo and dividendo. What it says, if a by b equal to c by d, then a by b, a plus b by a minus b equal to c plus d by c minus d. Okay, so applying componendo dividendo here, so you can write this as, so a plus denominator b, and similarly numerator minus denominator. Okay, and in the right hand side we have 2 plus 3z bar plus 4z bar square plus 2 minus 3z bar plus 4z bar square, and 2 plus 3z bar plus 4z bar square minus 2 plus 3z bar minus 4z bar square. Okay, so this will get cancelled, and the denominator, this will get cancelled. So in the numerator there are two terms, so in the denominator also two terms, so we can write this as, and 2 plus 4z square by 3z equal to same 3z square. Okay, and 2 plus 4z bar square. Okay, so 3 will get cancelled and 2 also will get cancelled. So at last we have this expression. Okay, now simply cross multiply. Okay, so z bar plus 2 z bar z square and z plus 2 z z bar square. Take to that side, so we have z minus z bar. Now uh, okay, let me write once again. This z z bar square means z z bar into z bar, so z bar equal to z square. Okay, and this is 2, just a minute, 1. This z bar will remain, and this is 2 z square into z equal to 0. Okay, now take common as this z minus z bar, and this is minus of 2 z square, and here it is z minus z bar equal to 0. So one expression is this and another expression is this. So either z equal to z bar, which is not possible because it is given that it is a non-zero imaginary parts, and second thing is mod z square equal to half, so half means 0.5. So this is the answer. The first answer is 0.5. Okay, now come to the second question. As z bar denote the complex conjugate of a number z, if the set of all complex number, the number of distinct root of this equation. So z bar minus z, let me write. So question number 5. So z bar minus z square equal to I of z bar plus z square. Okay, so what we can do is taking this in the denominator. Okay, now again apply same componendo dividendo principle. So you can write here as z bar minus z square plus z bar plus z square divided by, and in the right hand side I plus 1 divided by I minus 1. Okay, now this will get cancelled and this will get cancelled, so 2 will also get cancelled. So in the numerator we have z bar, and in the denominator we have z square with the negative sign, and here it is I plus 1 by I minus 1. So what we can do is we take this negative sign there, so we can write this as 1 minus I, so this is positive. Okay, now you rationalize this right hand side. So we have in the denominator 1 plus 1 means 2, and in the numerator 1 plus I whole square. 1 plus I whole square means 2I. Okay, now this is nothing but I. So what we have here is this by z square. Okay, so just write z square as z bar divided by 1. 1 by I, 1 by I means minus I. Okay, now what we can do is you multiply both side with z. So z cube equal to minus I into z bar. So z into z bar is mod z square. Okay, now come to this equation. Okay, so we have to find the value of this uh, complex number z with number of how many number of distinct solutions. Okay, so which means we have to find the value of z. So you see, simply this is a real number mod z square, and z cube is nothing but minus I into z to the power 2 by 3 and 1 by 3 means cube root of negative 1 negative minus I. So which means if we plot the circle, so this is the radius, that is mod z to the power 2 by 3, and this is our minus I. Okay, so we know from this cube root of unity this has three solution. Okay, this one and this one, whose angle between them is 120 degree. Okay, so there are three solutions. So number of solution is, okay. Now this is the third question. This is from the paper 2, question number 11. uh, Z bar is a complex conjugate number of a complex number z. If z is a non-zero complex number, both real and imaginary part of this expression are integers. Okay, so let write this expression. So this is uh, a complex number whose both the real part as well as the imaginary part is uh, integers. Okay, so okay, what we can do is first let us simplify this a little bit. So let's say z bar, sorry, z bar square divided by, what we can do is we multiply uh, in the numerator and denominator by z bar square. So we have z bar whole square. Okay, now we can take common. So what we have here is 1 by 1 plus this z bar means mod z square and whole square means 4. Okay, so z bar equal to mod z square. So square of this term is to the power 4. So we have here is mod z square into 1, this is mod z to the power 4 mod z to the power 4 plus 1. Okay, now this expression is nothing but a plus ib. Let's see. Okay, where a and b are integers. Okay, now what we can do is z bar square equal to cross multiply this. Okay, now let this, this is a complete real part, so we can write this as k for the sake of easiness of this calculation. So this z bar, let's say z bar equal to x plus iy, sorry, x minus iy, because let's say x equal to z equal to x plus iy. So what we have in the right hand side as x minus iy whole square equal to k into a plus ib. Okay, now x square minus y square minus 2xy equal to k a plus ib. Okay, now comparing this real part and the imaginary part, so this is ka and minus 2xy equal to kb. So let's find the value of x square plus y square whole square. So we can write this as x square plus minus whole square, and this is plus 4 x square y square. So this is x square plus y square whole square. So x square plus y square whole square means we can write this as uh, mod z to the power 4. Yes. So because we have assumed this as z equal to x plus iy. So let's say z equal to x plus iy. So mod z equal to x square plus y square. Okay, mod z square. So this is z to the power 4. So this is z to the power 4 means this is k square a square plus this is k square b square. So k square taking common, so we can write this as a square plus b square equal to mod z to the power 4. Okay, now what we can write is put k square in this expression. So we have z to the power 4 equal to k square. K square means mod z. K is this, so k square means mod z to the power 8 plus mod z to the power 4 plus 1 whole square, and this is a square plus b square. So this one term will get cancelled. So this is z to the power 4, and so we can write this as z to the power 4 plus 1 whole square equal to z to the power 4 into a square plus b square. Okay, now if we open this, so we can write this as z to the power 8 plus 2 z to the power 4 plus 1, taking this complete expression in the left hand side. So this is 0. So now we have uh, z to the power 4 common. So just a minute. So we can write this as uh, a square plus b square minus 2 plus 1 equal to 0. So we have uh, z a quadratic equation in terms of z to the power 4. So z to the power 4 equal to, taking using quadratic formula, so we can write this as a square plus b square minus 2. This is b plus or minus b square. B square means a square plus b square minus 2 whole square minus 4ac. 4ac means 4. So this is 4 and divided by 2. So further we can simplify this. So we can write this as plus or minus, this is 2 square, so a square plus b square, and then a square plus b square minus 2. So this by 2, and this is z to the power 4. So now mod z equal to, let's say this is uh, to the power 1 by 4. Now this is the expression. So now we have to check with the options. So let me write this expression here. Okay. So we have found our mod z value as, so let's say mod z equal to a square plus b square minus 2, and here all options are positive, so we take the positive value only. So in the square plus b square, and a square plus b square minus 4 divided by 2, this whole to the power 1 by 4. Okay, now check with the options. Let's say, so this where a and b are integers, where a and b are integers. Okay, now check with the first option. So let's say 43, let's say this is square plus b square minus 2 equal to 43. So 43 means a square plus b square equal to 45. So this is 45. Okay. So uh, okay, if a equal to, say, let's say 6, yes, and b equal to 3, so this is satisfying. Now this is okay. uh, Check this, put this in the inside, so we can write this as, say, 205. Okay, so 205 means 41. So this is 5 into 41, and take 3 inside, so 3 means 9. Okay, so this is 9. Okay, now 41, a square plus b square, and a square plus b square minus 4. So this is a square plus b square minus 4. Okay, 41, and a square plus b square is 45. Okay, you see, so this is correct. Okay, now let's check another value. A square plus b square equal to 7. So it is not possible for any values. Okay, yes, so this option is wrong. This option is also wrong. Now, okay, multiply by 2. So 2 means 7 by 2. Okay, so this is wrong. Okay, now 4 means, if we multiply in the numerator by 2, so we have, uh, this is also not possible, because a square plus b square, this is 7 by 2, so this is not possible at all. So this is also, a square plus b square minus 2 is 9 by 2, so this is not possible also. Okay, so all these wrong answers are correct, so the only answer is option A. Okay, so this is all for today.